Let's continue with distinct types. Distinct types are like other type aliases, but they provide type safety so that it is impossible to coerce a distinct type into its base type without explicit conversion. So we can specify that we want a type dollars and it's a distinct float. So it won't be like automatically assumed whatever value we give it to be dollars. So if we can create a variable a and say it's 20 and we convert it to dollars, okay? Because this is, we need to remember this. Let me just copy it. You need to remember that this here, this called dollars with the dot is the same as this or the same as this, right? $20. Could do that, no problem. Or just 20 dot dollars. I'll be happy. And here, this doesn't compile because this is an integer. And it's like, you can't put integer into distinct float. If you would try to put 25.5, again, it doesn't compile because the float 64 is not the same thing as distinct float 64, okay? It will work only if we'll actually convert it to that specific value. So, we can't just misuse it suddenly. Okay. However, when using distinct types, none of the base type's procedures follow the type. To solve this, it is possible to create lots of procedures that basically act as a thin wrapper for the underlying types, or the borrow pragma can be used to automate generation of procedures. So we can say we do multiplication. We define the asterisk, what do you call it, operator that takes A and B of dollars and returns a dollar. And we specify borrow. I guess it will look up that, hey, this is a distinct of this thing. And if this float in this case has the multiplication defined for it, it will just try to borrow it and do it. I really like that. Okay, because I was already wondering, like, it's really fun to be able to do that, but do I need to define all the operators suddenly? What about math? That's another thing that I'm not sure about. We could test that, right? If math would work on that. So let's see. We have all that here. Let's remove those doesn't compile or something. We have our procedure, multiply and add borrowed. So suddenly we can say that the variable a is $20 times $20 or just plus, right? Echo a. Oh, expected 1. Okay, so I guess we will need to do also define the dollar operator, right? And we do basically the same thing. We just do a dollars and returns string, save. And now we can print it out, right? So let's see. There we go. 40. Bam. I really like that. But of course, if we wanted to make it a bit nicer, we could do equals and we do just the float, I think. And we just add the character $sign in front of it. We just save. And will that work? There we go. $40. There we go. We did it. We properly render it now while reusing the way the float is being formatted. Okay. Gosh, that was so easy. Okay, what's next? When creating a distinct type from an object type, none of its fields are carried over. If the fields are wanted, they can be brought over through an overloading of the borrow pragma. If they are not borrowed, they cannot be accessed. What the hell? So we define the type foo, which is an object that has a field a, and then I want to say my foo is distinct foo. So again, they are not directly compatible. And we do borrow and specify the dot operator. Oh, so the dot operator is so that we can call this. Oh, wow. I must say this is weird. And I wonder if you can define your own pragmas. That would be something crazy. But okay. So we can basically, it's just some gymnastics that I need to remember when doing that. That's too bad. That's a bit too bad. I mean, at this point of my knowledge about NIM is so little that, I don't know what is the reason for it. But, that's just me right now.